Hey students, this is your Professor Omelianchuk, and today I'm going to talk to you about normal form, or how we can make every compound well-formed formula into a disjunction, or why might that be useful. Alright, so here's an exercise that you'll be doing on your homework for homework 5 is you'll get a table, right, that's got the two atomics. We got Fa and we got Ga, and then we have this unknown well-formed formula here. All right, and so you might want to talk about that and what does that mean? What's going on there? And so let's take a look at what it is. Right, it is false under the conditions when F and A are true. All right, and then it's true when we have TF, and then all right. So it has this FTFF pattern. So you might think, okay, so how are we going to determine what this unknown formula is? Is there a method which we can represent it? All right, so that's the big question. And what I want you to do initially here is just to focus in on the row where it's true. Right, that's important. And so what we'll do then is we'll take a look at the atomic parts of this formula, right? That are going to make this true. Now you might be wondering, well, what are those going to be? Well, it's going to be Fa and Ga. All right. Now there's going to be something special about the Ga though, given that it's false in this case. All right. So what we're going to end up doing, right, is put these two things together like so. Now I realize that not Ga is not an atomic part, right? That's actually a compound formula, because it has a negation attached to it. Fa is atomic because there's no connective to it. But the reason why we make not Ga, well, we put a not in front of the Ga, is because Ga is false. We can always identify, right, the negation with the falsehood of its atomic. And so we can take that falsehood of the atomic, and that's going to be equivalent with not Ga. All right, so this is actually a formula that is equivalent with the unknown one here, and so we could substitute the unknown one with this one. All right, so that is a form of normal form. Now I know that's not a disjunction, okay, and so there's reasons for that, but this is a kind of normal form, and I'll explain that. Right? Okay, so what if we have two truths? Okay, so here you have two rows that are true. This row is true. So what you do now is you make a disjunction of disjunctions, okay? Because this unknown formula up here is coming out true under the circumstances in which Fa is true and not Ga is, that Ga is false, which makes not Ga true, right? So that represents that piece. Okay, so that's one thing, that's one way that this becomes true. Another way, or it comes out true, right? There's the or. It comes out true under this condition here. Fa, which is false, so we'll put not Fa, and Ga being true. So what ends up happening then is that this whole formula then can substitute for the unknown formula, okay? And so that's why I say, hey, we can make every formula into disjunction. Well, not everyone, of course, because you have to have multiple truths involved, right? So if you go back, right, to the slide back here, you only have one truth, and so now you have the two atomics, and so that's going to be a conjunction. That's in normal form, though. That's okay, all right? There's no problems with that. So in this case, we have a disjunction as the main connective, because we have two possible ways this thing can come out true, okay? Just to prove this to you, if we fill out the truth table for the formula, it's going to be exactly the same as what the unknown formula says. Okay, so we're going to solve for the main connective here, which is the OR symbol, which is in red. And you know what? I'll just kind of plug in my truth values where my atomics show up. And then I will invert the truth values where the negations show up, like so. Now I'll solve for the conjunctions, right? I'll find the two places where they're true. That's going to be in the case where both sides of the conjunction is true. Then in every other case, I know that it's false, right? And now I'm going to solve for the main connective. So in that first row, we have a false and a false, right? So that's going to be a false, okay? And then I have a true and a false. It's going to be a true. And then I got a false and a true, so that's going to be a true. And then I got a false and a false in the last row, so that's going to be a false. And wouldn't you know it, I have the exact same values under the main connective here for my normal form sentence as I do under my unknown sentence, okay? Here we have a more complex problem. We have now 3 different rows where it's true, okay? So what we're going to do is represent those, okay? And we have 8 rows to count, and so we're going to have 3 atomics to kind of take count of. And so this first, so we just find the rows where it's true. There they are. And look at that first row. Everything's true. So what we're going to do is say FA and GB and HC. That's going to just, you know, mimic what's going on right here. Right? In this one, GB is false. So I just got to note that FA is true. GB is false, so I put a negation in front of the GB. And then I have HC being true right here, okay? Then the next row, okay, now I have 2 falsehoods. GB and HC are false, so those get negated, but FA is all good. All right, so I now have 3 different possibilities that make this unknown formula true, and so I just represent them like so, right? I just connect them up with my little ORs like that, okay? And so basically I'm done. Now you might be wondering, well, wait a second, now it doesn't look like you're done. You might be wondering, what's the main connective, right? What's the main connective here, right? You know, is it this one or this one? Or is the main connective, you know, what's going on inside here? It doesn't seem like this thing's well formed, right? So when we're trying to answer this question, you know, we could put parentheses in where we'd like. And you might be thinking, well, wait a second, don't you need a kind of principled way of doing that? And the answer is actually no, because it doesn't matter, all right? The reasons why is that conjunctions and disjunctions as well, by the way, are associative. Okay, so you get the same results no matter how the components are grouped. So you might think back to math class where you had to work, you had to study order of operations. And suppose you had, you know, 7 plus 2 in parentheses, and then outside the parentheses you had plus 1. Well, you do the order of operations. 7 plus 2 is what you got to do first, and so that adds up to 9. And then you take your 9, add it up with the 1, and you get a 10. And that's going to give you the same exact result as if you put, well, let's put the parentheses around 2 and the 1. Now you get a 3, add that to 7, and you get 10. You get 10 either way. Those 2 equations in math are associative. Right? That same sort of property actually translates into logic with respect to conjunctions and disjunctions. Right? You're going to get the same results under whatever you choose to be the main connective. Okay? So that's just what that is. Okay? So they're the main connective. Here you have and is right here, but it's going to say the same thing as this, where and is over here, right? Like I said, the same is true of disjunctions. Okay, you can get the same exact truth values under the main connective, no matter what you do. So what we do in normal form is that we can relax our bracketing practices, right? Since we know this, it's just not that big of a deal to fuss with parentheses all the time. All right, now if we kind of go back to the familiar arrow, you know, here you have FA, GA, and then it's FA and GA are joined by an arrow, and so you get this familiar looking truth table that says TF, TT. And you know, you could make a normal form sentence that is equivalent with the FA arrow GA, and there it is, all right? Typically, assertions in disjunctive normal form are longer and more complicated than their logical equivalent simpler versions. All right? So you don't use this very often, except when you kind of have unknown things. However, there are some shortcuts, right? So if you kind of take a look at the second row in the yellow there, what we can actually do is we can see not only which of the models are true, but all others which are false. And so in this case, you got this row 2, which is false. And so you know what we'll do? We'll just pick that one out, and we'll say, hey, there it is. And we got not FA, or I'm sorry, we have FA and not GA, which is negated. Okay, that negation is the falsehood, right? It's negating this conjunction right here, right? So today is a shorter lecture, all right, because normal form is kind of simple in how it works, right? So what I want you to do is to actually just work on these practice problems, right? And I want you to try to convert these things into disjunctive normal form, right? Using your truth table, your truth table skills. The reason I'm wanting you to do this practice is because you kind of need more practice of just drawing truth tables up, getting good at them, and learning how to do them and make them work, right? And you'll have to do this on your homework. There's an answer sheet, by the way, for this, so you can check that out. Follow that link when you get the lecture slides. And we can talk a little bit about the homework and how to do it. I think what's going on in this one, let's see. There is a section here. I'm pulling it up. That's why, if you're wondering why it's taking so long, is that here is the homework. Now I'll go over some of this stuff in the next lecture, but here's homework 5, and you will have to use disjunctive normal form to determine what the unknown formula is. All right, so in this case, right, you're gonna figure out what it is, and yet, hey, if you only have one true there, you can do the same. You can actually do the little trick where you actually identify the falsehood in normal form. Okay, here's a little one that's a little more complex, and then you have to convert these formulas into normal form. But first, you got to figure out, right, what does the truth table say? What does the main connective even say? You got to figure out that first, and then put it in normal form. Okay, so a lot of students end up kind of screwing this up because they only do one or the other. You got to do both to get full credit. All right, so I'll talk more about this homework because there's some other problems that we'll be doing that are coming up. But the portion of this lecture is relevant to this homework, so I want you to just be aware of that. Okay, so that's the lecture. It's not a very long one today, so that is normal form. And if you have any questions, of course, just let me know. You can let me know by email or ring me up in the Google Hangout thing, and I will talk to you later.